In the middle of the San Francisco Bay lies an island warehouse where a team of invent this. Nothing beats swimming in the sea for fun and exercise, but finding yourself in trouble on an ocean swim can be a real problem, even for experienced swimmers. So, living on the coast themselves, these four beach brains take a walk in the sand to postulate on a prototype.
The U.S. Life-Saving Association estimates that between 60 and 80% of U.S. beaches are unguarded.
Unguarded? 60 to 80%! You're 24 times more likely to drown in unguarded water.
We've got a great idea for a build.
Okay, guys, it turns out that 60 to 80% of American beaches are totally unguarded. That's a lot of beach that you could go and drown at and no one would ever know. It's time to bring life-saving into the 21st century.
I actually go swimming in the ocean every few days, and it can be really scary out there. If the tides change, you can literally get in over your head.
Many people get freaked out in the ocean, so it'd be nice for them to have some kind of system that's like on the beach, you can deliver a life vest to them.
Right, we've got to figure out a way to get that life vest or life preserver from the beach out to wherever the person is in trouble.
So we need to make some kind of launching system to shoot that life vest out there.
Air cannon.
But what if someone's out in the water way farther than the cannon can reach? What if we had some sort of airplane that could fly out there?
Right, an autonomous drone could go as far out as it needed and drop that package exactly where the person was.
Well, let's build both. We could do the air cannon for short range in the surf zone, and then the airplane for something that's out at further sea.
Sounds like a plan. Who's doing what?
Air cannon.
I guess I'll look into getting an airplane and flying it.
Zaz, we have to figure out the automatic aiming and firing system for the cannon, and also some sort of autopilot system for the plane.
Sounds complicated.
Yeah.
And how long are we going to give ourselves for this one?
2 weeks.
What's the worst that could happen? We could fail, right?
And with that, the flying lifeguard takes wing. The team will attempt to create 2 prototypes designed to rescue drowning swimmers on an unguarded beach. The first is an autonomous drone, an unmanned plane that will respond to the signal by a swimmer in trouble by automatically launching, flying to the swimmer's location, and dropping a life vest with pinpoint accuracy. The second device is a short-range automatic system that zeroes in on the swimmer's location and delivers the life vest in one fast shot from the shoreline. This is a challenge of his own. He and Kevin will be spending the day building an air cannon from the ground up. First, a steel base is welded to support the cannon mechanism. A slippery plastic disc is put in between the cannon and the base to allow it to rotate a full 360 degrees, so it can shoot in any direction.
Beautiful. We're doing the prototype disc. We're building the cannon. I don't know, Kevin, that's a pretty short barrel.
Oh, we need is.
Next, the precision-cut barrel is added to the base.
This is gonna have quite the bang for the buck. Are we putting this in?
Heavy-gauge hoses are attached to supply the compressed air. And after a late night, Terry and Kevin leave the shop with the cannon ready to be tested. The second week of a 2-week build begins. The cannon's being taken on its first day out for ballistics testing.
We're going to set up a high-speed camera, and we're going to have a field of view so that we can see the muzzle of the cannon. So we'll crank the cannon up to a known angle. We'll start firing it. We'll fire it a few times, and we'll just measure how far the projectile goes. Yeah, that looks good.
Zaz needs consistent launch measurements in order to start programming the automatic targeting software.
3, 2, 1.
But as soon as the first shots start flying,
Into the parking lot.
the cannon team's next challenge becomes clear.
The conditions today are not optimal. The wind is wreaking havoc. We're getting at a higher altitude, we're getting a lot of wind drift.
Big wind.
Big wind!
3, 2, 1.
Even though the high winds in the park match the conditions they'll face in a beach rescue, the windy weather is unsuitable to collect the readings Zaz needs.
Look at the spread here. This is identical pressure, identical elevation angle. They're all over the place. That variance is being caused by the wind.
The cannon testing's been blown off course. Zaz will have to wait to get the data he needs for the targeting system. And soon, Help for a swimmer in distress comes from above in the latest innovation from Prototype This, the Flying Lifeguard. They're attempting Oz's back on duty dull and early the next morning as the cannon comes out to play in the park once again.
Yes.
Since gusty winds ruined the last cannon test, Terry's on.
You ready for me to play target again? A good result from this set of testing, first will be some good precision.
Oh yeah, this baby's ready.
So we'll fire multiple shots at a given elevation angle. We want all those projectiles to land in roughly the same place.
But once the projectiles are in the air,
Fire!
the landings are still inconsistent.
Fire in the hole! 3, 2, and fire!
And Zaz is still unhappy with the results.
Well, as you can see, we're getting a reasonably large variance, even in these still conditions.
3, 2, 1.
Oh, took out part
Is inconsistent, even when there's no wind. How can it ever achieve accuracy? Zaz thinks he might have the drop on the answer.
The repeatability of this cannon, in my view, is shot. We're gonna have to redesign the projectile.
And while the cannon deals with a barrage of challenges as time is running out, on the long-range footage from the park and notices an error in the cannon that's a huge hindrance to its accuracy.
After watching the high-speed camera, you can see that the barrel is actually moving quite a bit. 2 degrees on this end is going to be a heck of a lot of feet on that end. I'm going to hold my finger on the bottom of where the barrel is right now, and this barrel is 3.5 inches in diameter. You can see it start to move up. And at the time the projectile comes out, you're looking at, you know, a good inch that the barrel's moved up.
And once the barrel's locked off at 30 degrees, the plan will be to increase or decrease the air pressure to get the life vest where it needs to go.
To be able to vary the pressure to select your distance and keep it locked off at a certain angle, I think is probably going to be the way to go. Oh, that's solid.
After taking an hour to repack the self-inflating life vests into the redesigned projectiles,
We started, you know, with a kind of naive design that just, you know, looked like a bullet. And we're into this real kind of missile mortar shell design that I think is well put together and hopefully will fly pretty straight.
it's back to the firing range, park once again.
I don't want to be moving this thing out here anymore.
With the autonomous plane still in pieces, it's the last day of a 2-week build. The cannon is ready for its final test, full automation.
We're here for the final integration test for the cannon. And what's gonna happen is I'm gonna go out into the dinghy out in the Great Lawn, push the button on the wristband transmitter. The cannon's gonna automatically calculate where I am, adjust the pressure, fire a life-saving device right to me. Using the anemometer, we're gonna measure wind speed and direction. All that stuff's gonna be processed through the electronics, sent over the network to Zaz. His computer is gonna calculate the firing solution.
So with helmet on and dinghy inflated,
All right, guys, I'm gonna head out there. Try to hit me.
Joe takes his place in the park, ready to hit the distress signal button. The only thing missing is the ocean.
I'm confident that we've got things working and this is going to be a success and we'll be ready to go out there and save lives. Okay, we're completely live. So when you press the wristband button, you're going to have a package heading your way, so heads up.
All right, I'm going to push the button in 3, 2,
1.
As the barrel angles in on the GPS armband and the air pressure is calculated for optimal distance to the target, Terry hovers over the kill switch in case something goes wrong. The first shot is their most accurate yet.
Yes!
It travels 160 yards straight and true to land a few feet away from Joe.
How far was it? 4 feet. Yeah.
Since the goal was to land within swimming distance of someone in distress, at 4 feet, the cannon's putting the life-saving solution right in the bullseye. But can it still find Joe if he changes range and position?
Okay. Awesome. All right, move the boat.
The answer is an unequivocal
Oh my God.
yes. The projectile misses Joe's boat by only 3 feet and misses the cameraman by mere inches.
You almost nailed him. That was.
Yeah, that's what we've been trying to do.
Yeah. to see the cameraman roll out of the way right next to Joe. I think.
Site of some of the world's most challenging waves. The cannon's put on solid ground. The launcher sled's unloaded, and a whirlwind begins. They have a life to save today. Joe's our intrepid aquanaut again, so Zaz fixes him up with the GPS distress signal, and soon Joe's out to sea. The Zodiac raft drives him to the crew boat, far enough out to really need saving. Joe jumps into the cold Pacific Ocean, and all alone in the water, he gives us his point of view.
Hello again. I'm Joe Grand, your favorite lonely electrical engineer, and
Laptop. The cannon seeks his position, setting the precise air pressure for distance.
Here we go.
1 degree, 99 pounds.
And the cannon fires. The redesigned aerodynamic projectile spirals just over the brake line. The life vest hits the water, but did it hit the mark?
Mike says it landed 10 to 15 feet away from him.
yay! Victorious, finally!
Joe says it looked like it was homing in on him.
The cannon was the easy than just prototypes. They're actual working life-saving devices that, with money and development, could be saving swimmers in trouble in a matter of months.